no shield against gravity, and the electromagnetic force is infinite in range. But in order to focus on basic principles, it is useful, that's debatable, to postulate such a system to clarify the nature of physical laws. That's debatable. In particular, the conservation laws can be postulated to be exact when referring to an isolated system which was just said not to exist. That is circular thinking. Now that's where fractals come to the rescue. Because in a fractal, every system is related to all other systems. And when you write the math, when you write the physics, you're then taking in consideration all of the rest of the components that are occurring in order for that system to exist. The electron cloud and the atom is continuous because it's continuously interacting with the rest of the universe. It radiates energy, and that energy eventually curves back into it to generate gravitation, and out and in and out. And when you start to see it that way, then you can do something that's really nifty. You can look at the subatomic particle. See, the other thing quantum physics did is when they found the nuclei of the atom, now they were deep in doo-doo already, right? When they found the nuclei of the atom, they noticed that the protons were all positively charged and all stuck together in a teeny bitty thing in the middle of the atom. They calculate, you know, when you take two magnets and you try to push them towards each other, right? How they push against, right? Now they tried to calculate how much force organization theory, not chaos theory. Because basically what chaos theory proves is that whenever you think it's chaotic and it's random, you can always find a higher point of perspective in which you find organization. But since that would be going against the concept that the universe is going towards further entropy and that everything is always going towards further disorder, they called it chaos theory, just to confuse everybody. But chaos theory is really a theory that proves that there's no such thing as chaos, but that there is only different levels of organization. I was looking for something to see here. Where we were. So we were finding that the structure, we're just going to do a little quick, oh yes, go ahead.
I had a question about, one of the last things you said was about strong force and had to the gravitation in the black hole. Can you repeat that?
Okay, what I was saying is that when quantum physicists found that the protons were all stuck together in the middle of the atom, they calculated how positively charged particles could be that close together. They would have to have some huge force holding them together because they have a tendency to move away from each other because they're all positively charged. They calculated how much force it would take to hold them together, and they called that force a strong force. And basically invented a whole brand new force, which they didn't say where the force was coming from. You remember? Because quantum physics says we don't care about causation, we can invent anything we want. So they just invented a new force, they didn't say where it came from. Actually, when they found the quarks, they found that the quarks had to be squished together as well. So they made the strong force the color force at the quarks level, just inventing forces. And they basically, what I'm saying is that if you consider quarks and protons as small mini black holes, and then you calculate, you know, how black holes would have a gravitational field. If you calculate the gravitational fields for these mini black holes, then the gravity that these mini black holes generate is strong enough to hold the particles together. And you don't need no strong force or color force, basically, that were just pure inventions of modern physics. Do you see what I'm saying? So all of a sudden, you see, one of the problems in current physics is they can't relate gravity to the strong and weak force at the atomic level. But that's because they invented forces that don't belong, you know? And you just got to re-examine how you're looking at these subatomic particles with the force you already have, which is gravity and electromagnetism, and then all of a sudden it all starts to make sense. You see? Yeah. So basically, this morning we saw that there was very fundamental errors in our concepts of dimensions, and then we saw that these, these concepts can be described and corrected. These concepts can be corrected by using a fractal analogy. And I want to mention that the fractal analogy is much more than just an analogy. It is a whole new way of writing physics, which accommodates for singularity. Basically, the largest error in current physics is they can't deal with singularity, so they make it like it's not there. And so basically, for instance, Bohm was a collaborator, physicist that collaborated with Einstein, and he tried, Einstein's field equation, he wrote to try to unify physics. And he was trying to find a unification theory from the beginning, and he never succeeded before he died. But Bohm was on his case saying it's got to be holograms. It's got to have to do with holograms where every part contains all information and so on. And Einstein was wanting to use hologram, but holograms are not mathematically applicable. It's a nice analogy, but there's no mathematics that are useful in hologram that you can apply to the field equations. However, fractals are mathematical equations that can be applied to physics. The other thing that's amazing about fractals is that a fractal equation is a reiteration of an equation that is deterministic, meaning the equation itself is deterministic, a circle and a triangle, right? But when you reiterate it, it becomes an open feedback to infinity. So it has a completely non-linear, non-deterministic output, right? So from a very deterministic equation, you get a complex, non-linear output. And so you're accounting for both sides of the universe, the deterministic part and the non-deterministic part. So we saw that we can solve these dimension problems by describing dimensions different resolutions.